Thank you for your interest in LinearBench Analyze, the industry's first comprehensive LRS data analysis software from Gistic Research. LinearBench Analyze is powered by patent-pending, grid-based LRS segment join technology. Analyze makes complicated tasks, whether LRS analysis or LRS QC, accessible to all users with its intuitive UI design. A complete commercial off-the-shelf solution, LinearBench Analyze offers several advantages. It can be deployed without the need for data model migration or data conversion. It features asynchronous communication, which enables continued use while multiple lengthy analysis operations are underway. And Analyze is fully integrated with LinearBench Explore, Gistic's LRS data visualization software. This integration allows for further exploration of generated reports in its straight-line diagram, time-space diagram, and map tools. Our demo of LinearBench Analyze consists of two videos. In Part 1, I described the software's LRS analysis operations. In this second video, I'll demonstrate its LRS QC capabilities. Analyze appears as a separate tab in LinearBench Explore. In the left panel, parameters are set to define the route or route segments to be analyzed, the operation to be performed, and the resulting report. At the bottom is a grid that contains saved analysis reports and their settings. The center of the window displays the results of a selected report, and on the far right is the map panel, which spatially displays those results. I'll begin by demonstrating Analyze's Route QC, or quality control capabilities. In this first example, I'll perform a QC of the Arizona Department of Transportation's LRS state route network. In ADOT's system, all state route names are preceded by the letter S. To select ADOT state routes, I can enter S followed by an asterisk in the route filter. A corresponding value will appear as an item in the route dropdown. Once selected, you'll see it in the Selected Routes area. Next, I'll open the Operations Definition area and select the analysis function to be performed. Here I'll select Route QC. Analyze detects 14 different error or warning conditions, categorized as either a completeness, geometry, topology, or measure error. Missing or duplicate routes, or route attributes, is an example of a completeness error. Routes with switchbacks is a geometry error. A topology error or warning might be route gaps, while difference in length between GIS measure and route measure is, naturally, a measure error. The four fields that appeared when I selected Route QC are the error conditions that require user-provided thresholds. The minimum route segment length criteria sets the threshold for calculating the smallest acceptable route segment that will not be considered an error. The minimum gap size on route criteria sets the threshold below which warnings will be raised. For this example, I'll just accept the defaults. The last step is to name and describe the resulting report. Here, I'll use the system-generated report prefix and the recommended report description. And since I don't want others to know my data may have errors, I will leave the report marked private. When I'm done, I'll click the Generate button and processing will begin. As you can imagine, QCing more than 1,500 state routes, with over 2,600 miles in length, will take some time. The report queue lists the reports in process and their statuses. Because of Analyze's asynchronous processing capability, I'm able to continue our demo while the Route QC report is running. This time, I'll perform QC analysis on a layer. After selecting Layer QC in the Operation dropdown, I'm prompted to select an LRS layer to analyze. For this example, I'll select Speed Limit. Then I can select which, if any, additional topology rules to apply to the analysis. There are 3 topology rules: domain, gap, and overlap. The domain rule identifies LRS data records having route measures beyond the range of their corresponding routes. The gap rule identifies places along the route where no LRS data records exist, and the overlap rule where LRS data records in a layer overlap. For this example, I'll select all 3. I'll enter a name, slightly modify the report description, and make it a private report before clicking the Generate button. Now the report queue area shows 2 reports in progress. When processing of the Route QC report is complete, a message appears saying it can now be found in the Saved Reports list. I can sort the saved reports by date to easily find it, and then click on that row to view the results in the panel above. We can see a few warnings for route gaps and errors with switchbacks. Let's set the report filter to switchbacks first. I'll check the Map checkbox on this switchback entry. The map window zooms to the problem area. When I turn on the WFS layer and zoom in a few levels further, we can see the switchback which should be corrected. Now the layer QC is also complete. This time, we'll use the straight line diagram to visualize the layer QC issues instead. First, I'll switch the linear referencing method to route measure. Let's look at state route 68 from milepost 21 through its end at 27.892. I'll now open the layer QC report and add the speed limit layer. Viewing this data on the straight line diagram helps us validate the overlap and gap. This is the end of part 2 of our LinearBench Analyze demo. If you would like more information about LinearBench Analyze or any of the other LinearBench Suite products, please send us a message from the contact page on our website or give us a call. Thank you for watching.